Hello friends, welcome to the online course Digital Design using Verilog for absolute beginners. In today's lecture, we discuss Verilog operators, their syntax and their utilities with various examples. All of you know Verilog is a hardware description language, and to describe any hardware we require some operators. And you also know that an operator works on any data or operand and gives the expected result. To describe any hardware, a language should have as many operators as possible. Similarly, Verilog language also supports various types of operators. Let us see one by one how they will help us in designing the digital systems. But one important thing about these operators is all the operators are not synthesizable. That means when you consider the Verilog language, when you consider this Verilog, we have two important things. One is a simulation, the other is synthesis. As I have already told you in my earlier lecture, synthesis means converting a data flow model into gate level model. That means acquiring or getting the netlist. So some of the operands or operators that we use may not be synthesizable. So that the user must remember. And most of the operators that we use in Verilog are similar to operators that we use in C programming language. That is also another advantage for the user or for the learner to easily remember these things. And another interesting thing is each operator type is denoted by a specific symbol so that the user can remember that. The different types of operators supported by Verilog are I have listed below: assignment operator, arithmetic operators, logical operators, relational, equality operators, bitwise operators, reduction operators, shift operators, concatenation and conditional operators, etc. In this lecture, I will try to explain each operator with a sufficient number of examples so that you will have not only a theoretical knowledge about the operators but get some or practical knowledge also. Let us go forward. The first operator is assignment operator. Those who remember the data flow model already come across this assignment operator. Verilog uses the equal sign to denote the assignment. The left-hand side of the assignment is the target system. The right-hand side RHS contains the input arguments and can contain both signals, constants, and operators. Operator means here logical AND operator. So here an AND operation is performed on the operands A and B and it is assigned to Y. Similarly, we are representing this a constant. F2 is assigned with a constant. Here, as you know, 8 means it represents the size 8 bits. H means it is a hexadecimal number. Its value is AA number. A, or you can also consider this as simply the alphanumeric value A. Now, the next operator or most important or fundamental operators are arithmetic operators. Broadly, there are two types of arithmetic operators. One is unary, the other is binary. Unary operator means where the operator works on only single operand, whereas a binary operator means the operator works on two operands. That means the operator will be in between. On both sides you will have the operands. So as you know, the basic arithmetic operators addition, subtraction, multiplication, modulus, exponentiation, division or divide. I try to explain this with simple examples. Say for example plus a minus y minus of a plus b, two stars, exponentiation. These are all unary operators because only one operand is there. Plus is an operator, a is the operand. Similarly, the other cases. What about the binary operators? As I have told you, a binary operator is an operator that operates on two operands. Here, A is one operand, B is another operand. In between, we have an operand. Similarly, B, C, sorry, and the in between. And suppose I consider this as a total operand and this as a separate total operand. In between, you have a multiplication operand. The same is the case with division. Similarly, this is an operand and this is an operand. In between, we have an operator. So these are all binary operator where you have two operands. For to make you to understand clearly, I have taken one simple Verilog code where I have used various arithmetic operations. As you know, the code starts with module. Name of the module I have chosen as arithmetic. Here I have chosen some inputs A, B, etc. Y1, Y2, Y3. These are all outputs. Same as I have explained, declaration of the input outputs are directions of the input data, that is input 2 down 0. That means it is a 3-bit, it's a vector. A and B are vectors. Similarly, outputs are 4-bit. Y1 is a 4-bit vector, this is a 5-bit vector, the remaining 3 are 3-bit vectors. And as the output stores the value, they are defined as range. Now let us always at A or B, that is this is whenever either A or B changes, perform these things. That is A plus B, this is an operator, addition operator. So addition operation is performed and assigned to Y1. Subtraction operation is performed and assigned to Y2. Similarly, multiplication operation is performed and assigned to Y3. Division operation is performed and assigned to Y4. Similarly, modulus operation, A modulo B, performed and given to Y5. So here you will have some doubt about the modulus. Let me explain with some other examples about the modulus operator, because many students will have the doubt on this modulus. What is actually the modulus operator? The modulus operator is denoted by the symbol percentage, and what it will do actually, it gives the remainder when the first operand is divided by the second. Suppose I say A modulus B, A modulo B otherwise. Then what it will do? It will B will divide A and it gives the remainder. So remainder will be this. So now let us see here. I have taken some example. 10 divided by 3. When I divide 10 by 3, the remainder is 1. That will be your result. Similarly, 11 modulo 3, 2. 12 modulo 3, 3. So here we have some interesting things. Minus 10 modulo 3. Here I have, you read this. The result of modulus operation shall take the sign of the first operand. So here the first operand has the sign negative. Therefore, the result is also having negative sign. That is minus 10 modulo 3 means. So definitely we have minus 1. So because 1 will be used for sign, the remaining is number. So here the result takes the sign of the first operand. Similarly, 11 modulo minus 3, 2. So the result takes the sign of the first operand. Here this is first. So don't get confused here. Minus 1 used for minus sign and the remaining 1. Here as the first operand is a positive, therefore that is unsigned. So definitely the result is 2. I hope you have understood this. Otherwise, you just practice once or twice, the concept will become clear. Now, the next is most important, logical operators. This operator deals with the true or false logic. As you know, logic means either 0 or 1. Normally, 0 means false, 1 means true. So, these logical comparison operators are used in conjunction with relational and equality operators. So, we'll see what are relational and equality operators in the next slides. So, at the present, let us take what are this exclamatory mark symbol, logical negation, logical not. What is an example? I can take A and logical and B and it is negated. Similarly, this is logical and logical OR. When I take two parallel lines, it is logical OR. Example A logical OR B. So here I have two operands. In between, I have an operator. So this is a not, this is a function. So this is similar to your hardware gates, not gate and gate similar, but these are all functions or operators here. Let examples also. So what are the other important things about the logical operators? Logical operator produce one bit result. That is, when I perform logical operation on two operands, the result will be of one bit. The result logical and ampersand is 1 if none of the operands is 0. Very important. How do you take the result? This you should understand carefully. When I take ampersand means logical, and in this time the result is 1 if none of the operands is 0. If both operands are only 1, if they do not contain 0, the result is 1. Similarly, in the case of OR, two parallel lines, is 1 if at least one of the operands is non-zero. That means which is non-zero means 1 normally. So the negation operator complements its operand and produces either 1 or 0. So let us see this with some examples. Here you can see I have taken some values, numerical values. A is equal to 3 bit, where the values are binary bits 101. B is also 3 bit size with 000. C is same 3 bit 01x. X means as you know unknown. Here what I have done, I have taken not negation of A. When I take up negation of A, automatically obviously what it will do, so the result it will be 0. Similarly, negation of B, because when I take B 1, it will become 1 1 1. At least when the values are 1, the result will be 1. If there is at least 1 0, the result is 0. Similarly, negation of C. So since there is one unknown, the result is also considered as unknown. Let us take up A ampersand B logic AND. So obviously what we have seen here, A and B, when I take up, if at least if all the values are 1, then the result will be 1. Otherwise 0, because 1 0 0 0 0 0 1 0 0. So the result is 0. Similarly, B ampersand C. So here we have 1x. That's why the output is also of x means unknown type. When I take up A parallel B, if one of the operands at least is non-zero, yes, here we have non-zero, this is 1. So definitely the result will be 1. When I take up the OR logic of B and C, definitely there is one unknown. Definitely the result will also be unknown. So this is the most interesting thing and important thing that every student has to understand. So in order to give further clarity, I have taken one example through a program also. Module, example logical, A, B, C, D, E, F, Y, where A, B, C, D are the inputs, vectors 3 bit, and Y is the output. Y is defined as a register, always at. Whenever these values changes, what happens? If A is equal to B means whenever A is equal to B and C greater than D or not of E less than F, make this as 1. Else make this as 0. That is assign 0 to Y. Whenever this is true, that is logical. Whenever this value is true, that means whenever this entire operation is equal to value is equal to 1, make Y is equal to 1. Else make Y is equal to 0. That's what we have taken earlier. So these are all normally used to decide some logic, either 1 or 0. So this is about the logical operators. Next, another important is relational and equality. I have combined both. So relational means we know whether greater than or less than, greater than or equal to, less than or equal to. What is equality? We have two types of equality operators. You can see here when I write two equals, equal, it is an equality operators. When I keep a negation before not equal or inequality operator, this is equality, this is inequality. And another most important thing here is 3 is equal to. This is called case equality. This is case inequality. So this case equality is one of the most important thing, because many people get confused with equality and case equality. They will have a doubt, what is this equality, what is this case equality. Equality means this will be possible only with the logic values 0 and 1. It won't consider x or z, g otherwise. That means if there are two numbers like 1, 0, 1, the other number is also 1, 0, 1, then we can check the equality. Suppose in a number 101x, another number 1011, then it cannot check this. Equality operator will not work. It won't work with either x or z operands. Whereas case equality will work both x, z also along with the logic 0 and 1. That means even if it is 110x, 110x, yeah, this case equality can find whether they are equal or not. This is the basic difference between case equality and equality. Remaining things, greater than or equal, less than or equal, greater, less. So this is about the relational and equality, where I have covered one example. So module, example relational, AB are inputs, y1, y2, y3 are outputs. As usual, y1, y2, y3, y4 are defined as range as usual. Yes, let us come. So y1 is a less than b. That means whenever a is less than b, this value. So y1 will be assigned this value. Whenever less than or equal to b, check, and then only that value will be assigned to y2. Whenever a is greater than b, then only the output will be assigned to y3. If a is greater than b, then the output is assigned, y4 is assigned with 1. Else, y4 is equal to 0. So operators. Let me take one more example for equality operators. So here you can see y1 is equal to, it is normally a equal to b. That is, whenever a is equal to b, when all the digits of a are equal to b, other than x and z, as you know, then y1 is equal to 1. If they are not equal, y1 is equal to 0. y2 is not of a is equal to b. That means y2 is equal to 1 if not of a equal to b. If both are equal, y2 is equal to 1. Else y2 is equal to 0. Similarly, if a is equal to b, that means if a is equal to b, equality operator, then y3 is equal to a. If not, y3 is equal to b. So this is the beauty of using equality operators. They are very useful, especially in comparing two signals. While comparing the two signals, this type of equality operators are very useful in Verilog. Similarly, next one is bitwise operators. Verilog bitwise operators can be either unary or binary, as usual in the case of similar to your arithmetic operators. Result is always the size of the largest operand. This is the most important thing. In bitwise operators, the result is always the size of the largest operand. That means I am performing bitwise operation of two operands. One is having 3 bits, the other is having 4 bits. The result is always 4 bits only, because it is always the size of the largest. So how do we do this? Let us see. That is, the meaning is logical bitwise operators take two single or multiple operands on either side of the operator and return a single bit result. The only exception is the NOT operator, because NOT operator will have only one operand. It will not have two operands. It will normally take only negation operation will take only one operand. Verilog does not have the equivalent of NAND. Remember, we don't have NAND or NOR. What do? We take AND with negation or with negation. AND with negation will become NAND, or with negation will become NOR. You can see here in the examples. Bitwise NOT. It is also called inverse operator. Bitwise AND. Bitwise OR. This is bitwise. This is bitwise exclusive OR. Exclusive OR. Then with NOT, then it will become NOR. This will become NOR. So bitwise operators operate on each bit, that is importance, and returns a value that is also a bit. Let us see with an example. If two operands are unequal, as I have told you, the smaller one is left extended by adding zeros. That's what I have shown here. I have chosen A is equal to 4-bit size 1001, whereas B is only 3-bit size of 101. What we have to do now? I add 1 0 here. So what B is equal to 4-bit size. It has become 0101. Then we can perform the logical operation A and B. When I perform logical operation, then it will become 0001. This is the result is 1. So the size of the result is also 4-bit. That's what I have explained in earlier. It will always take the size of the larger operand. Another example. Suppose A is having the value 1011, 4-bit, same. B is 1101, C is 0111. Now let us take negation of A. What will be the negation of A? So it should also be 4-bit. So what will be the negation? So 1 means 0, 0 means 1, 0, 0. Negation of B. Similarly, negation of C. A logical and B, as you know. B, A or B, A or B. 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1. Similarly, A exponential. Sorry, terribly sorry. A XOR B. It is also A XOR not of negation of B. This is important. So that's how we can understand with these examples. Simply take a paper and pen and just check these values. Definitely will understand the concept. Similarly, I have taken another example. So where I have tried to. So here what we have done is I have taken a vector data A 7-bit vector, B 6 bits. Output Y is 7 bits. Similarly, this is as usual treated as register. So in this 7 bits, Y0, Y1, Y2, Y3. What is Y of, that is the first value, Y0. Y of 0 is E of 0 and B of 0. That's AND operation, binary AND operation or bit AND operation. Similarly, Y of 1 is E of 1 and B of 1. So not of E of 2 and B2. Like this, you can define these operators. Next, reduction operator. So as the name itself indicates, reduction operator means it will reduce the size. So it will reduce a vector. Normally vector means multiple bits. It may have 4 bits, 7 bits, 8 bits. When I have 2 operands, if I use a reduction operator, the size of this operand will be reduced to 1 bit or a single bit. Suppose I have an operand with 4 bits. If I use a reduction operator, it will come to 1 bit. So this is, so where do you observe this type of things? You can recall that suppose I have a multi-input AND gate, multi-input OR gate, where there will be 4 inputs and there will be only 1 output. What it is doing? It is taking 4 inputs and giving you only 1 output. This is this. The symbols may be same, and negation of, and that's called a NAND, NOR, NOR, NOT or XNOR. So let us see this. So I have taken a simple example here. I have taken an AND gate where the inputs are 1, 0, 1. You can also call in hardware 4 input AND gate. What will be the result according to AND? Even if one of the data is 0, the output is 0. So 1, 0, 1, 1 is reduced to 1. That's why they are called reduction operator or reduction operation. Similarly, OR gate here. I have chosen OR operation 1, 0, 1. Even if one of the inputs are 1, the output is 1. You know the OR gate. So here also 3 inputs are reduced to 1 output. 4 inputs are reduced to 0 output. This is example. Let us have another example. Here I have chosen one XOR gate. So what is the meaning of this? Y XOR A means, suppose A is the input, 4 bits, 0, 1, 1, 0. That means 0, XOR 1, XOR 1, XOR 0. Definitely, obviously what it will do, or what will the output? Output Y is equal to 1. That means 4 input bits are reduced to 1. So this is the case of what you call reduction operation. So to make you understand further, I have taken one more example also. Same way, that is assign A, I have given some value. A is 0, 1, 1, 1. B is 0, 1, 1, 0, 1, 0, 0. Then same thing, y1 is equal to x1. XOR operation of A. That means when you perform XOR operation on this, definitely as you have seen just now, y1 is equal to 1. Same thing, A XOR B, it gives y is equal to 0 if I perform. So that's how a 4-bit or 8-bit or multi-bit values will be reduced to 1 bit. That's why they are called as reduction operators. Similarly, a known or very well known or very important operator is shift operators. So normally, as the name itself indicates, the shift operators are used to shift the operand bits either left or right. So shift operators require two operands. As you know, what are these? The operand before the operator contains the data and that is to be shifted, and the operand after the operator contains a number which gives the number of times the data is to be shifted. That is the most important thing. How many times, how many bits are to be shifted. So Verilog has two types of shift operations. One is a logical shift, the other is arithmetic shifts. So logical shift means where the vacated positions are filled by zeros normally. So the shifting is done in two ways, either left or right. As you know, left shift or right shift. So normally right shift is denoted by greater than greater. Left shift is denoted by less than. So as I already told you, in logical shift, vacated positions are always filled with zeros. Zero. Of course, if it shifts by 2, then 2 zeros will come. In terms of the operation, right shift means divided by 2. This is also very, very important. Similarly, left shift operation means multiply of the operand by 2. So, arithmetic shift operation. Right arithmetic shift operation, instead of 2 greater, we'll see greater, 3. The symbol contains 3 greaters. Similarly, 3 less than. It is a left arithmetic. So in arithmetic shift for signed numbers, the vacated position is filled with signed bit value, mostly MSB value. For unsigned, as usual, it is filled with zeros. So this is an example simple with a Verilog code. I have chosen A as the input, Y1, Y2 are the. So I have shifted A, logical shift. So when I say logical shift, if I don't mention anything here, that means it will shift only by once. Similarly, right shift as well as left shift I have taken. Similarly, another important operator is concatenation. Many people will have it out. Concatenation means they assume that it is addition. No, remember, this is not addition. This is a simply combining two operands to get a single operand with extended bits. That is the most important thing. So remember, concatenation or concatenating means simply combining, or not arithmetic addition, combining simply two operands so that I get a single operand of larger size. Here you can see A is equal to 4 bits, 1 0 1 1, B is equal to 1 0 1 0. When I perform this concatenation operation, y is equal to A comma B, it gives A is 1 0 1 1 1 0 1 0. 4 plus 4 total 8. That's why I have chosen the size as 8. Here it is 4 bit, here it is 4 bit. Now the result is of 8 bit. It is concatenated, or this operation is called concatenation operation. Similarly, there is another operator called replicate. Replicate means simply copying, duplicating. So this operator replicates the operand for a specified number of times. How many times it is to be copied? This is the advantage. So instead of writing or typing every time, suppose this operand will give the number of times that data is to be copied. That is the most important thing. So when I write assign y is equal to within the brackets 3, again this curly braces 3 bit size B110, then it will copy this 3 times. That means 110, 110, 110. That's why this size has become 9. I think It's clear to all. The example is clear to all. Conditional operator, that is a question mark. An expression using conditional operator evaluates the logical expression before the question. This, if the expression is true, then the expression before the colon is evaluated and assigned to the output. If the expression is false, then the expression after the colon is evaluated and assigned to output. I think I have given a simple example earlier also, a multiplexer example, 2:1 mux example. Of course, module, name of the module, AB are the inputs, S is also input, Y is the output. So here I have written assign Y is equal to S question mark B semicolon A. What is the meaning of this? When you evaluate this expression S, if it is true, that means if its value is 1, then B is assigned to Y. If its value is false, that is 0, then A is assigned to Y. Very, very important. Again, I repeat, conditional. What is that condition? This will be evaluated. That is the left hand side of the operator is evaluated. If this is true, that means when S is equal to 1, then B is assigned to Y. That means Y is equal to B. Else Y is equal to A. This is known as conditional operator. Thank you for watching, and please don't forget to post your feedback.